Good morning, student. Today we are going to learn about pulse width modulation and demodulation. After the completion of today's session, you are able to draw the block diagram and waveforms of modulator and demodulator, explain the generation process of pulse width modulated signal, describe the demodulation process of pulse width modulated signal. First we discuss about the generation of pulse width modulation. So this one is the block diagram. Block diagram consists of sawtooth generator and comparator. So for every comparator we have to give two inputs to the two terminal of a comparator. So the modulating signal x of t is applied to the non-inverting input of the comparator. The sawtooth generator generates the sawtooth signal. The sawtooth signal, also known as sampling signal, that is applied to the inverting input of the comparator. Okay. The output of the comparator is high only when the modulating signal x of t is higher than that of sawtooth waveform. So here the sawtooth waveform is act as carrier signal. So when x of t is greater than c of t, then only at the output we get a positive values or higher signal. So when the x of t is less than c of t, at that time at the output of the comparator we get a 0 value. Okay, and the output of the comparator is the pulse width modulated signal. See here, if the sawtooth waveform is like this, okay, then here you can see this is the sawtooth waveform and this line is the modulating signal. Okay. So here the leading edge of the leading means when the pulse is increasing. So here you can see the leading edge of the pulse width modulated signal is fixed. Only the trailing edge will be modulated. So in this waveform, where the x of t cross this slanting line, okay, slanting line means this point, this point, this point, this point, this point, from that point we map the lines and draw the trailing edge of the pulse. So we can say that the leading edge of the pulse is fixed and the trailing edge is changing, means here we can say it is modulated. If we use in place of sawtooth waveform a triangular waveform, then both the edges are changing or modulated. So see here, when the x of t crosses the lines in both the side of the waveform, from that point we map the lines to down and draw the pulses. From that we can observe that both the edges, that is leading edge and trailing edge, both the edges are modulated. Okay, another one thing, if the sawtooth waveform is reversed, means if the signal is like this, okay, then trailing edge will be fixed and leading edge will be modulated. So like this we get our pulse width modulated signal at the output of the comparator. Okay, next is the demodulation part. Demodulation of pulse width modulated signal. So this is the theory part. We just go to the block diagram. So the block diagram consists of schemic trigger, ramp generator, synchronization pulse generator, adder, level shifter, rectifier and low pass filter. So first, when we receive the PWM signal, it given to the schemic trigger. Schemic trigger remove the noise in the PWM waveform. Okay. Then the regenerated signal is then applied to the ramp generator and synchronization pulse generator. The ramp generator produces ramps for the duration of pulses such that height of ramps are proportional to the width of pulse width modulated pulses. The maximum ramp voltage is retained till the next pulse. On the other hand, the synchronization pulse generator produces reference pulses with constant amplitude and pulse width. Then here internally a delay circuit is provided, which is not shown here. So the delay circuit delayed the reference pulses for certain amount of time. So the delayed reference pulse and the output of ramp generator is added with the help of adder. The output of adder is given to the level shifter. Level shifter shifts the waveform. Means here the negative offset shifts the waveform, then the negative part of the waveform is clipped by the rectifier. So here the rectifier is used as a clipper circuit. Then the output of the rectifier is applied to the low pass filter to recover the modulating signal. The whole thing we again discuss by seeing this waveform. So first one is the PWM signal received by the demodulator. Here you can see the surface of the pulses are not smooth, okay, because of the interference of noise. So when we apply that waveform to the schemic trigger, it removes that noise. So in the second waveform you can observe that surface is flat. Then the output of the schemic trigger applied to the ramp generator. So the ramp generator produces ramps for the duration of pulses. So if this is the whole pulse duration, then for the whole duration it produces a ramp. And the maximum ramp means this one is the maximum point. The maximum ramp voltage is maintained till the next pulse. So here is the straight line given. So that maximum ramp voltage is maintained up to the arrival of next pulse. So here at this point the next pulse is arrived from the schemic trigger. Okay. Then the synchronization generator. So the synchronization pulse generator produces reference pulses with constant amplitude and pulse width. So here you can see the pulses are generated by the synchronization generator. All the pulses having constant amplitude and pulse width. Then internally a delay is provided by the provided after the synchronization pulse generator, which provide delay to the reference pulses. After that, the delayed pulses or delayed reference pulses and ramp output of the ramp generator are added by the adder circuit. So here you can see the adder circuit simply add the ramp output with the synchronization pulse, means this one is the ramp output, and above that ramp output the synchronization pulses are added. Okay, then the output of the adder given to the level shifter just shift the negative offset. So here this line is present here in the adder circuit, but after the level shifter the line is shifted to this point and waveform, half of the waveform coming to below this line. So after that what happened, the rectifier circuit, or we can say clipper circuit just clip the negative part, means below this line the all waveforms present are removed. So only this much is present after the output of the rectifier. Then using low pass filter the signal smoothen out and we get our modulating signal. So this is all about pulse width modulated or pulse width modulation and demodulation. Okay, thank you.